Managing modern ACI environments often requires greater flexibility in how controller infrastructure is deployed and expanded. Cisco ACI 621 introduces support for physical and virtual APIC coexistence, enabling hybrid controller deployments within the same cluster while maintaining a single, unified policy plane. In this scenario, I'm starting with an existing physical APIC cluster and expanding it by adding virtual APICs into the same environment. Before adding virtual APICs, it's important to ensure that the footprint matches the existing cluster. In this case, since the physical APIC is an M3 model, the virtual APICs must use a medium-scale footprint to align with the cluster requirements. Once the virtual APICs are bootstrapped and reachable, I can begin adding them into the cluster from the controller management interface. I'll start by adding the first virtual APIC, providing its management IP and credentials. The system performs validation to confirm reachability and basic compatibility before allowing it to be added. After validation succeeds, I assign the required identifiers, including controller ID and pod details, and apply the configuration so it can be included in the cluster. I'll repeat the same process for the second virtual APIC, validating it and adding it into the cluster configuration. Each node is verified individually before being committed. Once both nodes are defined, I'll save the configuration. At this stage, the system performs a deeper validation to ensure that the new controllers meet all required characteristics, including footprint alignment and cluster compatibility. With validation complete, the cluster begins incorporating the new nodes. The system starts configuring the virtual APICs, and their status transitions into initialization and bootstrapping as they join the cluster. At this point, the environment now shows one physical APIC and two virtual APICs forming a single logical cluster. All controllers are visible within the same management domain. As the nodes come online, they begin synchronizing with the cluster. This synchronization process ensures that configuration, policy, and system state are consistently distributed across all controllers. From the CLI, I can also verify that all controllers are part of the same cluster, with nodes progressing through synchronization states until they reach full membership. At the fabric level, the leaf switches also recognize the updated cluster. The controllers are visible from the switch perspective, confirming that the fabric has acknowledged all nodes participating in the control plane. As synchronization completes, all controllers become fully operational. The system continues optimizing internal structures, including shard distribution, to ensure load is balanced across the cluster. In addition, internal structures such as shard ownership are recalculated and redistributed. This ensures that load is balanced across all controllers and that each node contributes appropriately to cluster operations. Once synchronization and shard optimization are complete, all controllers are fully operational and participating in cluster activities. With this, the environment now consists of both physical and virtual APICs operating together within a single cluster, maintaining consistent control and visibility across the fabric. This approach allows clusters to be expanded or transitioned without requiring a full rebuild, enabling gradual migration and more flexible deployment strategies. This demonstrates how Cisco ACI 621 enables cluster expansion through physical and virtual APIC coexistence, while preserving synchronization, fabric awareness, and operational consistency.